So we left off last time with a multiplier concept. Maybe I'll back up a little bit just to review some of this. All right, so there's a couple different multipliers that this chapter talks about. One is the one we did yesterday, which was the employment multiplier. So if we have an export job, then one of those jobs added to our city will lead to 1.13 additional jobs in support of it. And so that was our multiplier concept here. The average for the industry was 2.13. So a related concept is a spending multiplier. And how that goes is we have maybe a big event, or we can think about this characterized in terms of spending too, of how much money are people spending. So they were measuring dollars rather than jobs. So it's kind of similar. The way we walked through this one is we thought, I hire somebody, I'm paying them 80 grand a year and they live in Ottawa. Well, that person's gonna go spend some of their money at Pizza Time and Pizza Village and other places, and that'll raise employment. But another way to look at it is just the dollars that they're spending on pizza and employment, right? So we can think of it with spending, and we'll do that a little bit later, but I thought I'd bring that up to you here. This one's about jobs, but we can also characterize it in terms of labor. Okay, so that was just a quick recap, and then we had the demand curve with the multiplier. We'll a lot of times look at the final effect with everything multiplied out, but the idea here is to think in two pieces. We add a job because a new business came to town, and then those people spend money, and so that's kind of piecing it apart with the total effect on demand, giving us this bump up of employment by 21. Okay, so then we did this yesterday. We interpreted the elasticity. Why do people want to come live in our city? So we might be able to improve some amenities, decrease crime, decrease taxes, holding public services constant, or improve or increase public services, holding taxes constant. And so that gives us this look where we left off before. So where there's going to be upward pressure on a wage, we're never really going to get out to here with this demand analysis, that it's the interaction of supply and demand that's going to make that work. Okay, so here we go. Predicting what this wage will be. We can use some elasticities to do this, and we'll have some problems that we're going to work on here in a bit. So I've got this formula here. Let me just actually rewrite it in pen, because I like to look at things more as the fractions. So the percentage change in the equilibrium wage is equal to the percentage change in the demand with the multiplier over the elasticity of demand plus the elasticity of supply. And what's not shown there, your author doesn't do this, but we're actually taking the absolute value of the elasticity of demand. Remember that it's always negative, and so we're adding it. We're adding those two things together. Okay, so I put proof not required because to derive that formula, there's a few gyrations behind the scenes that you have to do. But it all ties back ultimately to our elasticity of demand, percentage change in quantity demanded over the percentage change in price. Here, it's also related to the quantity supplied over the percentage change in price. And so long story short, I'm not going to waste any more class time than I already am. Maybe I opened my mouth too much. But combining these two concepts, you can think of getting to here. How much is this moving from here to here? And it turns out to be that formula. So the wage would be the price, percentage change in price. If we're thinking, this is the beer market, right, not the labor market. So I'm just trying to kind of connect some dots. It's possible for you to derive that formula. And maybe if you take some upper division graduate school econ classes, you do kind of mental masturbation like that, and it's worth your time. But for here, all we're going to do is say that this is the formula. Okay. So that's it. Now, how does it work? We need some numbers on what the elasticities of demand are. So these would be given to you. So this, we've seen this already in this class, right? A study was done and it showed that the elasticity of demand is 2 and the elasticity of demand is 5. So we get those numbers from some outside analysis of the elasticities. And then we've got the change in demand being 21%. So with this picture, that was going from 100 to 121, holding price constant at 100. It would be a 21% change in demand in terms of the shift of demand. And so then we apply our formula. And what is the percent change in the wage going to be? 21 divided by 7 equals 3. Done. So then our 3 is here, the 3% bump in pay from 100 to 103. Okay, questions on that? I know it's just kind of some mechanics, but.
So you did say that it's just going to give us the elasticity of demand and elasticity of supply?
Yeah, a problem would give it. So, and what I'm saying is that like in the real world, these would be maybe known in the industry. And so then you could do this analysis to make a prediction of, hey, we have a new labor demand coming. We think it's going to increase the demand, or the demand curve is going to shift by 20%. What's going to be the effect on wages? And then you do that. Okay, anything else? All right, not quite done yet. What is the change in equilibrium employment, the number of workers? So what we did here brings us to the 3%, but now we end up here. What if a homework problem said, what is the change in quantity? What would you do? What would you do? You don't know that this is 115 here. And we're not going to we're not going to trust that our numbers are right on and we can kind of eyeball it. What is that number? How would you do that? Any thoughts? I will let you know there's enough information up here for you to calculate the 115.
It is or is not?
Tyler, there is.
I think you multiply the elasticity of supply by the percentage change.
Okay, good. So why are you doing that? So did you just piece together the 3 and the 5 and you came together with 15, or?
That's how I originally did it, but you can do it.
Okay.
You can do it in the formula.
That's okay. You can be an investigative, reporter type thing. Dig into the details. Okay, so yeah, you are right. So you're using the elasticity of supply formula, right?
Yeah.
So the elasticity of supply formula is the percentage change in the number of workers, is the quantity being measured on the axis, divided by the percentage change in the wage. And so we know this is 5 equals percentage change in workers divided by the percentage change in the wage, which we just calculated, was 3. And so the percentage change in workers equals 5 times 3 is 15. All right, I think while that's fresh in our heads, we're going to do a problem.
I have a quick question.
Yes.
Okay, so in the book it says the equilibrium wage is percent change in demand over ES minus ED, but you have it as absolute value of ED plus ES. So
Oh,
what
they
is it?
changed that then, I think. I'm glad you pointed that out, Andrew. So that is just, they left off the absolute value, and so it's just minus a minus is a plus, right? That's what I'm hearing you say. You on page 117?
Well, 116. It should be at the top, it should be 2 comparative statistics change in the demand.
Okay. So yeah, let's, I did not catch that. So when they revised this edition, I think this is probably the better way to do it. This is a negative number, so minus a minus is a plus. Okay, so I'll try to switch back to doing that one. Yeah, I didn't mean to throw a new formula at you. That was actually my old slides from the previous edition. So I'll try to clean those up. Good catch. Okay, so still same formula though. Yep. All right, that's what I didn't like about the way the author did it, is he didn't put the absolute value on the formula when he did it. He just kind of assumed that we were talking it that way, so that was a good edit on their part. All right, let's turn to the problems and do number 2. So number 2, consider the computer software industry. Assume labor is responsible for 80% of the production costs. Software is produced with fixed factor proportions. So again, that assumption means even if labor becomes more expensive, we don't start doing 15% labor and 85% machine. It stays fixed. That's all that's trying to draw out. The software market is perfectly competitive. When you see an assumption like that, what does that mean? It can mean a few different things, but the software market is perfectly competitive.
That is large number of firms.
Large number of firms would be one of them, but then there's more added on to that after that. Jameson?
The prices aren't determined by the company, it's determined by how many companies are right there.
Okay, and then a kind of a combination of a large number of companies and the price being somewhat externally determined by the market. What's true about profits? Equal to, what's price? They're equal to what?
0.
0. Okay, sorry, I just didn't hear you. So profits are equal to 0, which means price equals average total cost. So all of that stuff kind of kicks in a perfectly competitive market. The price elasticity of demand for software is negative 1.5. Suppose the wage of software workers increases by 20%. So compute the effects of the increase in wage on the equilibrium price of software and the quantity of software labor demanded. So this is labor demanded here, equilibrium price of software. So be careful with your elasticities, whether you're in the output market or you're in the labor market. So go ahead and work together on that one, see what you come up with. I'm going to try to edit this slide right now. definitely gonna wanna talk to each other on this one. A little, not the most obvious.
The only thing that makes sense about the wage is just because it's 1% there, but we can't do that because it's only people.
I thought you could switch.
Because you have elasticity, supply, percent change in wage.
Yeah, look, but the second of the two on software business factor proportionally. So that just means you just can't change the amount of work between machines. So I guess you could pick up the general machine.
I feel like they might use 30% of the workers, which would trouble them down in those workers.
I can, probably go two on me.
Using two up.
Two little higher. Which is software business.
You can't change that.
Okay, we getting anywhere? So that first part's the tough part with the 80% business. So what does it read about the 80%? Labor is responsible for 80% of your costs. So if labor prices go up 20%, how much does that affect your overall cost?
20%.
What, Jonathan?
20% of 80%.
Yes. So 80% of 20% is going to be the total impact to your cost, right? So labor is going up by 20%. So let's just say, pick a number, right? So maybe it's $10 an hour, just keep a number easy. A 20% increase would be $12 an hour. You're like, oh no, that's going to really affect my bottom line. Well, yes, if you are using a lot of labor, it would be a pretty big impact. But imagine that you only have 1% of your production costs are made up with that labor. So it's 99% other cost, 1% labor. Does paying that extra $2 to your labor matter that much? No, right? So it's just going to be a 1% impact to your bottom line if it was only 1%. Now 80% is a pretty good chunk. So how much of our total cost is going to go up? Because of the fixed proportions assumption, as Jonathan said, my total production cost is going to go up by 80% of 20%. Another way to look at it is if labor made up 100% of my cost, that's my only resource cost. So all of my total production cost, if we go back to putting on a little formula here, if my total production cost, equals basically wage times labor, right? It's my full labor bill. And now if this goes up by 20%, what happens to this? How much does it go up by? 20%. But now if my labor bill makes up 80% of my total cost and 20% is the rental rate on capital times the number of machines, now when this goes up by 20%, how much does this go up by? I don't know if you calculated it, Jonathan. How much, Tyler? 16. Right? So how? Because 80% of my total cost was coming from my labor bill, 20% was coming from something else. So when labor shot up by 20%, it's really going to be 80% of 20% of that increase. This, of course, went up by nothing, right? There was no increase here. And so my total cost went up by 16%. Does that make sense?
Yeah.
So kind of thinking about that. Now back to our perfectly competitive situation. What's going to happen to my price if cost went up by 16%? What happens to the price of my product? It goes up by 16%. So that other competitive assumption, so with competition, we have price equals average total cost. You can look at it that way. You can look at it as the total cost and divide it out. But basically, if this goes up by 16%, that means this has got to go up by 16%. Now you've got the ammunition to kind of do the rest of the story. So continue on with that information. You haven't answered the full question yet. So compute the effects in the increase in wage on the equilibrium price of software, and now you got to do the quantity of software labor demanded. As soon as you get an answer, spit it out. Negative 24%. Bryce is correct. How'd you do it? Actually, what? I'm done talking here for this little section. Come on up, Bryce. Show off your good work. Now, you always are sometimes bad not showing your work, so we'll see how you do on this. This is the part you need to. Let's do it over here. You can erase that. I was thinking about you bringing up your paper, but let's have you do the marker, since that's what you chose to do. That sounds fine.
So it tells me
Yep.
And then I know my percent change in price from what we did over there is 16%.
Okay.
And so then. that's
Good.
for
I'm
the
glad you added the
total
equal sign. I was waiting for that.
And
Okay. Or, you know, to do it a little more algebraically,
I'll multiply.
right, you'd multiply that around. Okay, good job. So he kind of just plugged the 24 in here, but really what we're solving for is the percentage change in quantity. And so now we put the 16 over here, the percentage change in quantity equals negative 1.5 times the 16% equals a negative 24%. Any questions? All right, what about part B? Suppose we relax assumption 2, which was the fixed proportions. The decrease in the quantity of software labor demanded would be larger or smaller? The decrease in the quantity of labor demanded. So here what happened, we had the 80% thing, but now we had a 16% bump. And so would the decrease in the quantity of labor, software labor demanded be smaller or larger?
Small,
Smaller? And why?
because we're gonna change our percentage there to have more of the cost on capital
Okay, so we can substitute now here.
on the other side.
And so if, to the extent we're able to, if prices were staying fixed over here, instead of keeping this 80-20 mix, we might be able to do more or less here. Less. So maybe we can bump this to 75 and bump this to 25, which means that the effect is going to be less to the extent that we can do it. Okay? That's the substitution of labor and capital that really goes on in the real world. All right. Let's see. Let's do this one. Number 4. We've got two cities, Control City and Freiburg, that are initially identical with an equilibrium wage of $100, equilibrium employment of 100,000 jobs, and a 50 million square foot of housing, 500 square feet per worker. The government in Control City fixes the maximum total square footage in the city at its current level. New housing can be built, but every square foot of new housing requires that 1 square foot of old housing be retired. Each city experiences an increase in labor demand that shifts the market demand curve to the right by 24%. In both cities, the wage elasticity of labor was unitary at 1. In Freiburg, the wage elasticity of supply is 5. Illustrate the market effect of an increase in labor demand, including the value for the new equilibrium wage. All right, there's a lot going on in there. Talk with your friends. See if you can wrap your brain around that one. don't hear too much talking. Compare notes. If you're totally stuck, you should be talking to somebody. You don't have to have the answers. Begin the discussion.
Use the equation that you had written here. Elasticity.
Pull out your phones for calculators. Run on airplane mode. Who's got it?
Halfway.
What's the change? You're halfway there?
I mean, I don't know how to illustrate the market demand thing, or the labor demanded.
For this one?
Yeah, I know, I've got the second part of it, the new equilibrium wage stuff, but I don't know what that first part is.
What'd you get for the wage stuff?
It's either 104 or 106. Let's say
104 or 106. Why would you have two?
The absolute value or not, so I did it both ways.
Either way works. The formula was the same. So it's 5 plus 1 is 6.
Okay.
Yeah, not to confuse. So Andrew just brought up that they wrote the formula as minus a minus. So you're always adding the two numbers in absolute value. So then what'd you get for the wage? 104. And what about the quantity then? 120. Tyler's got it. Okay. Tyler, come on up. Let's look at your work here. You got it. You got it. You got it. Be proud. Yeah, just put it on the document camera.
I only did the first part.
That's fine. Yeah, I was just looking for A at this point. All right. So tell us what's going on over here.
Alright, so
Looks good.
basically do the first
If you
formula.
point with your pen, and then we'll. Yep.
Do
there
the
we
first
go.
formula to solve for the percent change in wage in Freeburg. So we found the 24% because that was just given to us.
Yep.
And then 5 minus the minus 1, so divided by 6, 4%.
Okay. So that bumps us up on your graph here to 104.
Correct.
Right.
Yeah.
Okay.
And then now you do, this is elasticity of supply.
Okay.
So to solve for the, because originally like this equation solves for this point and then the shift along the supply.
Yeah. So what you could do is, what's this number down here that you
Yeah.
don't have? It wasn't asked for. but
Exactly.
What's that number? You guys at this old price? We were given it, but we weren't given the exact number, but we were given it 24%. So at holding the old wage constant, a 24%, what we're doing is a 24% shift of demand at the old price puts us at 124. And now we're calculating the rest of it. Go ahead.
Yeah,
I'll
now
let
you
finish
calculate
off.
the rest of it with the elasticity of supply times the change in wage, which we just found, so it's the 5 times 4, 20% increase, and then just 20% increase there.
Okay. Questions? Make sure you can show that. That could be on the test.
Sorry.
So all of these problems we're working through in class are potential game for the test. So when you go back to study for the test, you should be going back through your notes, through the problems that we worked through in class and your homework, of course, but we've worked through a lot of them in class. That's what's going to be on your test. I'm telling you, that's what you need to study. You need to know it inside and out if you want to get an A. Am I making myself clear? That's why it's important, like when we have Tyler come up and show that, make sure you write that down in your notes.
We need to memorize the formulas then.
Some of the formulas I'll allow a formula sheet. I've weakened over the years. I used to always have you guys memorize that, but I don't want that to hang you up. So that's not a big deal. We'll have some of the formulas. Okay, so what's this B part all about? In Control City, a plausible value for the wage elasticity of labor supply is one of these. Illustrate the market effect of an increase in labor demand, including a value for one of these new ones. So basically, what is a plausible value for the wage elasticity? So the wage elasticity in Freeburg was 5, and remember when we talk wage elasticity, we're talking about kind of the flatness or steepness. So I think what the author's trying to get at is if this is Freeburg, and this is a supply curve, would it be more steep, less steep for Control City? I should have did this is Freeburg. Is the Control City going to be flatter even or steeper? Look at the problem here, because that's what they're that you might have wondered, well, why are we talking about this Control City business, new square foot of housing versus old housing. Is it likely going to be steeper or flatter? So let's talk about the impact of this regulation. What's that look like? The question doesn't ask, but it might be kind of fun to draw it. So maybe in your notes you can do a little picture of housing in Control City. Quantity of housing, this is the price of housing now. Supply of housing, demand for housing, let's just pretend that it looks somewhat normal. We don't know what this number is, it's not given in the problem, but we do know this from the problem. What did the problem give us?
Square feet.
50 million square feet, 500 square feet per worker. So 50 million divided by 500 square feet means how many workers are being housed? 50 million divided by, I don't expect you to totally have that one off the top of your head. How many? 100,000. What's the number of employees in our little city? 100,000. Okay, so this is getting good. So whatever the price of the housing is, it is. But that's what it looks like probably in Freeburg. But now, or the old regulations before this new regulation was passed. Now, what's the supply curve look like? Kaylin, what's this mean? Give me some sign language here.
Because they're not getting any more workers,
It
now
would
they're
be
housing.
straight up and down, wouldn't it be vertical?
So yeah, this is the supply of housing units though that are 500 square feet per worker. So yeah, you're switching to this way, right? So at the quantity of 100, they're basically saying, sorry, we're not building anymore, right? We're gonna protect our local landlords, they've paid for lobbyists. And so the new supply curve looks something like this. An orange line. Okay, so now there's an increase of 24% demand. That's in the labor market though, remember, that's back to the problem. But what's gonna happen to housing prices? They go up, right? So if anything moves up, compared to what Freeburg's gonna do, their housing prices are gonna be less, and Control City's gonna go up in price. So, would that make their last, their elasticity of supply flatter or steeper? That's the question. Does that mean flatter or steeper in terms of their, now remember we're back in the labor market now, so let me just put that in here. So we've got the wage. This is the number of workers. And this is their wage. And so would it be like this or this is kind of conceptually what we're looking at in Control City.
It's gonna be flatter,
Flatter, why do you say that?
because not as many people are gonna want to deal with the housing prices going up, so the supply's gonna be.
So they're not gonna supply as much no matter what the wage is? How's that sounding to you? So they're gonna have to commute or something, right? If there is growth in that town. So do they command, are they gonna need a higher wage in order to induce themselves to work in Control City or a lower wage? A higher wage. Now, is that a 2? Where's my thing? I got it off screen now. So what's most appropriate here? A 0, 2, 5, or 7? Freeburg was a 5. So How do the numbers work again? Is this a steeper one is more elastic or inelastic? Which one's the 5 and which one's the 7?
Yeah.
7 is steeper, so let's go back to our elasticity of supply formula. Percentage change in quantity supplied over the percentage change in the wage, right? That's our basic formula. And so if this is a big number like a 7, the upstairs is a lot bigger than the downstairs. So is that the flatter one or the steeper one? Be the flatter one, right? So this is more elastic. So more elastic. And more elastic means a bigger number or smaller number? I can see all your brains getting scrambled, almost some smoke coming out of your ears at this point. Smaller. So let's just say, if this is a 7, any number can be turned into a fraction real conveniently by doing what? Put it over 1. A 1% increase in the wage leads to a 7%, boom, increase, as opposed to a 1% increase in the wage leads to only a 2% change in quantity. So which one's this one, the 7 or the 2? This is the 7. It's more elastic. All right, so that upstairs you're getting the bigger bang for your buck. And remember, this is the quantity. This is the number of workers, I guess, of the way we've been doing it. So this is workers. Okay, so this would probably be more likely. And maybe, in reality, what's a 0? Vertical. So a 0 would mean you can't pay me enough, or is it perfectly flat? So a 0 means a 0 is upstairs or downstairs? A 0, because you can't take 0 divided by 1, right? Or can you? Or is it 1 divided by 0? Which one can't you do? One of them's illegal in math.
1 divided by 0
You can't divide anything by 0, right? So if it is a 0, you can do 0 divided by 1.
Yeah.
And a 1% increase in the wage leads to a 0% change in the number of workers. Given our strict assumption, maybe that's part of it. So I would say we stick with either the 2 or the 1. You don't have, I don't think it's said here that they have to live in the city, does it? I don't think that's an assumption here, but. Yeah. So we could still live, I think, in Freeburg and commute over. That's getting a little beyond it. So you guys pick, let's have you guys, this half of the room, do 0. And you guys do 2. Because the last part says to calculate it. Illustrate the market effect of the increase in the labor demand, including a value for the new equilibrium wage. You're basically redoing the problem. You guys do 0, you guys do 2. You guys do 0, you guys do 2. As soon as you get an answer, shout it out. What did the 2s get?
I got 16.
16 on the 2 side here. So 16%?
Yeah.
Okay. Increased labor demand, so value for the new equilibrium wage. What'd you guys get?
I'm getting 0 last time.
Getting 0. Okay.
So here we have 2 plus 1. Okay, 24 divided by 3.
So you got 8.
Yes.
I think it's just.
What did you get?
I got 8.
Where does the 16 come
I don't
from?
know. You got excited.
Okay, 8.
I'm so confused.
We'd like to change our answer to
Change your answer to 8. Okay. Group consensus came to an 8 here. So how'd you get that? Let's start with the 2s here. So what was your math here?
24 and the percent change in demand.
24 for the upstairs.
Yep, divided by 1 for the elasticity of demand.
Right, because that stayed the same.
Plus 2 for the elasticity of supply.
All right, so you end up with 3. And so then you get an 8%
Increase in wage.
increase in wage is the wage, increase in wage, okay? So that's the increase in wage part, and then what'd you get for the quantity?
So, percent change in, I don't know what it stands for, but it was on his paper over there. And then it equals 2 for the elasticity.
So with a picture, what we're basically doing is now you guys have done this part, right? So we went from 100 to 108. And so now what's this part? We were at 100, and now what's this part?
160.
116? Is that right? I'm only hearing Jonathan. You guys don't seem to be supporting him.
Sweet.
Yeah.
Okay, and how'd you get that?
Math.
I don't know, ask him.
How'd you get that?
So I used his equation whenever he came up, which was percent change in I don't remember what it stands for, but equals 2 times 8 for the elasticity of demand times the percent change in wage, so that equals 16.
Okay, so we're kind of right here, right? Elasticity of supply, the response of the number of workers.
Okay.
So here, you guys, this is where we're at, right? So elasticity of supply was 2, right? Because that's what we chose. And then we got the percentage change in the number of workers divided by the percentage change in the wage, which you just calculated was 8. So 8 times 2 is 16. Good? All right, now what's my zeros? 24. Okay, so let's start with what we did here. So now your situation is a little different. The first step, we've got the 24. Did this change on you here?
Yeah.
Okay, so what is it? 24 divided by
1.
1, because it's 1 plus 0. So you got a 24% is the change in the wage. So now we come over here and we do the same thing, except you've got a 24 instead of an 8. And then what's this?
That's 0.
So what was your answer? 0. Okay? So you're applying the same thing each place, 0%, which actually worked out pretty nice, right? Because it tells the right story. Nobody else can live in our city with that type of restriction. Again, it's an economic model that kind of pushes the boundaries. But okay, questions or comments there? Woo! Wasn't that fun? Okay, so let's bring this chapter to a close so that you guys can work on your problems. All right, there's where we left off. Okay, so this kind of summarizes a few different things here towards the end. Some of it's from cities, real world data. So state to state elasticity, taxes, and business activity. So 0.2%, so a 1% change in one state leads to a 0.2% decrease in another. So an increase of 1 leads to a decrease of 1 in the other for interstate. Intrastate, city to city, is a little bit more responsive. So easier to move from city to city than it is from state to state, right? Which makes sense. Manufacturers are a little more sensitive to tax differences, and high tax on capital tends to repel capital-intensive industries. So if we take the 80-20 model that we've been using and we make it 80% capital, 20% labor, then that's the more capital-intensive industries, and taxes are going to have a bigger impact on that. Okay, so that's taxes and business activity. All right, so we did that part. Here's some other reports from studies. High service cities tend to grow faster, holding stuff constant, especially taxes. Now, what's nice about growing cities is that the tax rate can stay the same if I get more people to tax, right? So the tax rate times the number of activity is one reason why we see that happen, is that you can actually start providing more public services without increasing tax rates because your tax base has expanded. There's more people to tax, so you don't have to raise the tax rate, but rather because of the base. So I think that's part of that story there. So growth, they see some evidence that high tax isn't necessarily bad as long as you have high public services. However, they see cities that start to struggle with growth when they start to get into redistributional programs. What's a redistributional program? Give me an example. Jonathan.
Taking from the rich and giving to the poor.
All right, so that's the take from the rich, give to the poor. Basically, I have an idea for our city. We have to help the homeless. We're gonna build them homes, right? Very good intentions, I'm not gonna fault you on that. But we might see businesses leaving if you're funding that project through raising their business taxes, right? And it can be for other people too, just property taxes in general. So redistributional programs tend to not, the evidence shows that we haven't seen growth occurring as much as when here. So now, you give my kids a water slide and a park and a trail and access to the fishing pond, let's go. I'm willing to pay some higher taxes if that's what you're funding it with. But if you're doing it for redistribution, my heart is not that big, apparently. We're seeing self-interest saying, I'm going to help them the way I want to help them, maybe through church, maybe through other private means, but I don't want the government trying to figure that out for me as part of that evidence. So Detroit has been kind of a sad case for a long time, unfortunately. You know about the car industry changing. Well, they tended to do a lot of the redistribution type programs, and this study found in only 5 of 16 cases of those city incentives of, we'll cut your taxes, we'll do this, right? Kind of some city giveaways to attract new business to replace the old business that left. So that was kind of a common thing. A lot of cities besides Detroit have done that, but it didn't really help, right? In general, some of them even had negative effect. Imagine that. How could you get a negative effect? More people? Okay, so there could be that.
People see that another new business is getting a tax payment and is like, screw this, I'm out.
They say, I'm out of here. That could be. So there could be a lot of little underlying things that aren't there, that, you know, that maybe there was some external factors, but whatever it was, it had a negative effect. Like you said, the type of industry that it attracted maybe is not something I want in my community. So we give a tax break to, I don't know, the first thing that came to mind is chicken farms and turkey farms. Do those smell good? Have you guys driven past one? They got some smell issues, right? And so that sometimes gets fought, even if it might lead to development. So maybe if we do that, so we often see cities get into bidding war, and if they do offer incentives, they might be incentives beyond what would be economically efficient. Why are they doing that? Because Missouri did it. Missouri did it. We're Kansans. We can beat Missouri. Kansas raises their offer. Missouri says, no, you don't. I'm going to raise my offer too, right? And so you kind of get in a bidding war of who's going to get Google, who's going to get Amazon to relocate in their community. All right, stadiums. Good idea or bad idea? Got a bunch of athletes in here. You guys are all like, yes! I want that big. You guys saw the one in LA for the championship? That's kind of the latest one. That one looks awesome. Tyler?
So I live in Santa Clara. That's where the new Niner Stadium was.
Okay.
It was really bad for our city.
Is that right? How so?
It brought a lot of attention on specific game days.
Right.
And it brought a lot of jobs for those games, but
Yeah.
it wasn't, those were like all temp jobs. And so
Okay.
it didn't actually.
Good. It's good to hear you say that. That's
we're in debt now too, so that's.
and now you're in a big debt. Yeah. So you got taxes going up.
Yeah.
The job impact, it's going to be 100 jobs. Well, 100 part-time paying $10 an hour jobs or $15 an hour jobs, whatever, right? So we don't have the people making $100,000 a year come in. Now you might have the NFL athletes or something, but are they living in Santa Clara in your little hometown? No. They're over in LA and they fly in and they've got a second house in Miami, right? So they're not spending their $20 million paycheck on Santa Clara, right? So we got that same problem going in. And it turns out, long story short, that stadiums suck as far as a true economic growth initiative. Study after study says they suck. So we have some small benefits, some negative again. So look at what happened in Arizona. I believe this was for the Arizona Cardinals Stadium. 340 jobs, $240 million. Now the $240 million is what the city paid in tax breaks or whatever to create the 340 million jobs. Now, if this was 240, if I'm doing my math right, that would be $1 million per job, right? So granted, it's not $1 million, but it's not too far off of that, 700,000 or so per job, right? So this happens time and time again, but people get wrapped up in this part, I think. And that's a non-monetary benefit that does exist, but they call it civic or tribal pride, like I live in Arizona and look at that beautiful gleaming stadium and that's a part of me and I'm a part of it and I go cheer on my team, right? So some non-monetary benefits by that, but is it non-monetary benefits to the tune of $700,000 per job? There's some benefit, but I'm not sure it's that kind of benefit. All right, so that's probably good for that. How about environment? Predictions on demand and supply of labor. So if we have a cleaner environment, do more or less people want to supply their labor to my city? More, right? So that's good. Now, what about on the demand side of labor, the businesses? In order to have a cleaner city, what do those businesses need to do? Regulations. They need to be cleaner about what they do potentially. Or that's conceptually what we're looking like in the labor market. So there's production costs that are going to go up, and that could be through taxes. Maybe we have more city people running around, and so they're like, oh, well, we'll just tax the businesses more. And so that's going to cause some impacts. And the net effect for our city might be left in question. And it's going to depend on the size of the shift. So when we have the demand taxed, remember this is the labor market, so it goes a little bit different direction. I'm going to give you what I did in principles class when we have two curves shifting. We've got an initial equilibrium, supply and demand. This is in labor, and this is wages. And so if there's a tax on businesses for the pollution, then that's going to decrease their demand. Their businesses, their costs of production are going to be higher, and so they're not going to produce as much product, which means they don't need as many workers. So that shifts to D2. That's what part of those shifts are up there. So we're starting here at this initial equilibrium. And then what about the supply? They want to live in our city or they don't?
They want.
They want to, right? So the supply, once the tax is put in effect, if we actually got a benefit, then more people are going to want to supply. So supply would live like that. So now we've got this equilibrium. But the supply curve might have been here, or it might have been here, or it might have been here. The demand curve, I wrote it here, but it could have been here, or here, or here, or here. And so the actual number of equilibrium points are all at what in reference to wage? What do we know for sure happened when the government put this regulation in place? Wages went down. So here is the initial wage, and here's the initial quantity of workers. And so we know that all the possible equilibrium points are somewhere south of where we started. We could be an increase, we could be a decrease, depending on the size of the shift. So that's what the author's depicting here. That we'll be uncertain about one or the other, depending on the size of the shift. Okay, questions on that part? All right, so one last thing here. I know you're anxious, but hopefully this will be beneficial. So we got steel and clean. So suppose the steel industry gets hit with a pollution tax. Why does the wage go down for both? How does the distribution of workers change? So definitely with steel, the steel industry has this situation going on, right? So why does the wage also go down for the clean industry? What happens when the wages fall for steel? What do workers want to do? Leave and go work for who? Mr. Clean, Mr. Clean. And so when the supply of workers goes to Mr. Clean, assuming that their skills are substitutable, then that's going to cause the clean industry to have lower wages as well. All right, so I still got, I got a couple minutes left. This is easy. So there's kind of some cool studies that have been done that people don't always think about on the distribution of where these people are. So what happens when we have something come? We might have had part of the benefit of original residents who were not in the labor force taking up some of the jobs. Does that help my city grow?
Yeah.
Careful. On the face of it, no. There might be some indirect effects of that they're now employed and they might spend more money and maybe there's somewhat of a multiplier effect. But in terms of the number of jobs, if they're taking those jobs and they already live here, it doesn't help the city to grow any, right? So there's a little bit of leakage that happens with labor force participation. And so we had original residents who were out, we have original residents who came back in, and so it's not always easy to say that that's going to lead to an uptick when we look at existing cities. All right, that is it. We'll see you Thursday, short of Snowmageddon coming.